Alrighty guys, we're going to go ahead and get started with our momentum notes. So first thing I want to do is talk about the definition of momentum. Like, what is it? And I'm sure you guys have heard momentum before, whether you were playing a sport or something and maybe you made a good play, or maybe your team was losing and your team started coming back and they were like, nice, keep up the momentum. I can't really relate because my team never loses. We just repeatedly win everything. But for some of you guys, maybe you understand what I'm talking about. And in physics, momentum is just the mass in motion. So every object has mass, but not every object is moving. And when those objects do start moving, we can say that they have momentum. So therefore, if an object is moving, it will have momentum. There is an equation for momentum so that we can solve for it if we're given certain information. And that equation is going to be P equals M times V. I know it's kind of funky that we're using the letter P for momentum, but that's just how things work in physics. Sometimes we use weird letters to define weird words. So M is going to stand for mass, we know that. V is going to stand for velocity. And these things are still in their regular units, so mass is going to be kilograms, and velocity is going to be meters per second. And P, like we just said, is momentum. And the units of momentum, since it's just mass times velocity, is going to be the units of mass times velocity. So kilograms times meters per second. Let's talk about a few scenarios that involve momentum. The first one I want to talk about is what's happening when we increase one of those values. Well, if I wanted to increase the amount of momentum on an object, what would I have to do? The only way to increase momentum would be to increase mass or velocity. Because if we think about the equation we just talked about, momentum equals mass times velocity. So increasing either of those will increase momentum. On the other hand, if I wanted to decrease the amount of momentum an object has, I would need to do what? Well, I would need to decrease mass or velocity, because again, momentum equals mass times velocity. They are directly related. As one of those increases, momentum will increase. As one of those decreases, momentum will decrease, assuming you're keeping the other one constant. So is momentum a scalar or a vector? And we talked a little bit about this before, but essentially the difference between scalars and vectors is just that scalars are only numbers, and vectors can be positive or negative numbers because the positive or negative tells us a direction. And we're going to say that momentum can be a vector. And the reason why it can be a vector is because momentum can be positive or negative. How do I know it can be positive or negative? Well, momentum depends on velocity, and velocity can be positive or negative. Therefore, momentum will be positive or negative. Again, meaning that it is a vector. Let's talk about the conservation of momentum, if it's conserved or not conserved. So if we're thinking back to things that are conserved, well, we remember that energy is conserved. And momentum is just like energy. So momentum is also conserved. What does this really mean though? Well, this is going to tell us that momentum cannot be created or destroyed. It can only be transferred from one object to another. And we'll see that once we start doing some labs later on in class, that momentum is really just going from one place to another. Therefore, the amount of momentum at the beginning of the problem must be equal to the amount of momentum at the end of the problem. You cannot create it or destroy it, so what you start with is what you end with. Here I just have a quick little GIF demonstrating the conservation of momentum. I see these light bulbs moving back and forth. So this light bulb hits the next light bulb and you can see kind of that light traveling through it. Imagine that that light is momentum going from one light bulb on the left side to the other light bulb on the right side. Right here I have a quick little video about this astronaut in space that's really excited to show you how conservation of momentum works with tennis balls.
Conservation of momentum tells us that the total momentum in any closed system will remain the same all the time. And since momentum is equal to mass times velocity, even if you have multiple objects going at different speeds that might collide, for example, the total momentum of the system before and after the collision will remain constant. So for example, these two balls, which in this case happen to be of equal mass, whether one of them is moving and causes the other to move, or they're both moving and collide and move off in different directions, the total speed and the total mass of the entire system always remains the same. So for example, if this had a velocity of 0, and that had a velocity of 1, the first one might impart some of its momentum onto the second, but the total between the two remains the same. And that remains the same whether one remains still and the other comes to collide with it, or whether they're colliding with each other. It even works, in this case I put Velcro, it even works if these two stick together, the total momentum remains the same.
All right, now that we talked about the basics, let's talk about elastic versus inelastic. So an elastic collision is when two objects collide and then separate after they are in contact with each other. In other words, they are bouncing apart. So we are starting with two objects and ending with two objects. An inelastic collision is when two objects collide and do not separate after contact. In other words, they stick together. So this is a collision where you start with two objects and end with one object. Regardless, though, in either of these collisions, momentum is still conserved. We know that the momentum before, or P before, is equal to the momentum after. But something important to note is that velocity is not always conserved. So it is only conserved if the two objects have equal mass. Here's a quick video about elastic collisions, and I want to show you how when these objects hit each other or collide, that they remain separate. And now on the flip side, here's a video of an inelastic collision where these two objects hit each other and stick together. Now we're going to go ahead and try a practice problem. So before we do this practice problem, I want to talk about problem solving steps. And the first one is just draw a diagram of the situation so you can see kind of what's happening in the problem. Next, create a momentum chart of the before and after. And this is what your chart should look like. You'll notice that we have mass, velocity, momentum before the collision, and mass, velocity, momentum after the collision. Over here is where I recommend you write your object. So say object 1 and object 2. Always assign the left or the west as the negative direction and the right or the east as the positive direction. So when it says a car is moving to the left, we need to make sure that that velocity is negative. And when a car is moving to the right, we need to make sure that velocity is positive. So here's our first problem. We have two cars that are traveling along a road. Car A has a mass of 2 kilograms and is traveling east at 6 meters per second. Car B has a mass of 5 kilograms and is traveling west at 3 meters per second. After the collision, car B has a velocity of negative 0.25 meters per second. So let's start filling out our table below. We have the mass of car A and B. Well, it tells me car A has the mass of 2 kilograms and B is 5 kilograms. So go ahead and fill that out in my table. Next, I'm going to identify velocities. Car A is moving to the east, so that should be positive 6, and car B is traveling to the west, so that should be negative 3. Now I need to solve for momentum, and momentum is just mass times velocity. So for car A, that's 2 times 6, that gives me 12, and for car B, that's 5 times negative 3, that gives me negative 15. Now that I have the momentums, I can solve for total momentum by just adding those up. 12 plus negative 15, that's going to go ahead and give me negative 3 for my total momentum before. I know that total momentum before is equal to total momentum after. So I should have negative 3 after the collision as well. It also tells me that car B has a velocity of negative 0.25 meters per second after the collision. So I'm going to add that information to my table as well. And then I'm going to notice that mass does not change. These objects are still apart, so they should still have the same mass that they started with. So car A is 2 and car B is 5. And now I can kind of do like a Sudoku type thing and solve for my missing row or column. So I find out that the momentum after for car B is 5 times negative 0.25. That's going to give me negative 1.25. for my momentum after. And now to solve for the momentum after of car A. All right, so if we're solving for car A's momentum here, we need to remember that momentum is conserved. So the momentum after the collision should be equal to car A's momentum plus car B's momentum. We know what the momentum after the collision is. I'm just going to write that down here, -3. And the momentum of car A we don't know, but the momentum of car B we do know. That's -1.25. So now we can just go ahead and add this over to the other side and solve. We find out that car A's momentum should be equal to -3 plus -1.25. That's going to give us -1.75. And perfect, we get the right answer. Now that we have the momentum of car A, we can go ahead and solve for the velocity of car A. We remember that momentum equals mass times velocity. So the momentum of car A was -1.75. The mass of car A was 2, and the velocity is what we're solving for. So just divide momentum by mass, and we find out that the velocity of car A should be -1.75 divided by 2, which is just -0.875 meters per second. Awesome. And we can just fact check all this just by adding up our momentum and making sure that it equals the total. So if we look at the beginning, 12 plus -15 equals -3, we're good. -1.7 plus -1.25 equals -3, we're good. So we know that we solved this problem correctly. Alrighty guys, we made it to the end, so let's just go ahead and recap what we talked about. First things first, momentum is just mass in motion. Alright, if you are not moving, you do not have momentum. Momentum is always conserved, so whatever we start with is what we end with. Elastic collisions means that we bounce off, and like we said before, we start with two objects, we end with two objects. Momentum is just mass times velocity. That's our equation. So if we increase mass or velocity, we're going to increase momentum. And if we decrease mass or velocity, we're going to decrease momentum. Right or east is positive, and I have my compass above in case you forgot. And then left or west is negative. And that's really the main things that I want you guys to grab from our notes today.